Now this isn't a computer engineering class, so we're flying like 10 miles above the surface here. Broadly, computer systems are composed of hardware and software. The hardware is what you pick up. The software is the stuff that's written into memory that controls it. You know, you're sitting there and you're typing on your keypad or whatever, you know, you're running Facebook, you're going into the system settings to change things. That's all software. And then the hardware is all the physical stuff. You know, the devices that communicate with the internet, the screen, the touch screen, the keyboard, all of that kind of stuff. So broadly, we're going to categorize your hardware as 4 different types. And nowadays, they've gotten really blurred. Used to be, you know, in the 60s or 70s, you had input devices like keyboards, maybe mice. Your output device would be a screen, or a printer. Your processing, you know, is all that stuff that's located down there, you know, in the box or whatever. And then you had storage. Storage is broadly broken up into 2 things. One is the memory that your computer runs on, that it loads programs into in order to execute. And the other is the semi-permanent storage, like the hard drive or whatever, or your flash drive that you copy things onto to take home, or the SD card that you stick in your camera. This is just for fun, but I want you to see this. So you know what a trackball is. How would you like to use one that was the size of a bowling ball? So whenever they came up with trackballs in the 50s or whatever, you know, they didn't have perfectly machined, you know, small balls and gears that would operate them. You can kind of see how it works. If it rolls this way, it spins this wheel. And the wheel has holes punched in it so that there's some kind of sensor that can detect, you know, how fast or slow it's spinning that way. Same way this way, and hopefully if you curve it this way, it'll be spinning both wheels. And those of y'all who had to suffer with the kinds of mice that had scroll balls in the bottom, you know, knew that they would get gummed up or whatever, and it was not ideal, so the laser mice, you know, tended to be a lot better. Obviously, they've been miniaturized since then. That's pretty lame looking. You know, the mice were invented in the late 60s. Essentially, the idea of a more modern mouse was a trackball turned upside down. But that's not what the first mice looked like. They actually had these wheels. And if you wanted to move up, you would tilt it that way. And if you wanted to move to the side, you would tilt it that way. Obviously not ideal, but better perhaps than hitting the up arrow and the right and the left arrow in order to get to them. There were other weird input devices at the time that people tried out in the 60s. Not Engelbert Humperdinck. Doug. I'm probably misspelling his first name. I mean his last name. Engelbart. Okay, here he goes. This guy. I'm going to have to talk about Doug Engelbart someday. He came up with concepts that drove computing for the next 20 years. But here he's got his mouse, which is a real new thing. And here he's got this thing that looks like 5 piano keys. And the idea behind that is if you wanted to do one command, you'd press, 3 keys. If you wanted to do another command, you'd press, a different 3 keys. If you wanted to do something else, maybe you just press the left one. Nobody wanted to memorize, all these chord combinations in order to do that. I think that's about enough of that. Let's go back here. Like I said, nowadays they've gotten blurred. Your screen is both your input and your output, on your phone or your tablet or whatever. Nowadays, lots of people have touch-sensitive screens. Your keyboards, especially your fancy ones for the gamers, with all the options. Some people are actually buying or building keyboards where every single letter is an LCD, a display so that the character sets could change. Whole lot of blurring going on. But you know what input is. Input is when you're typing stuff into the computer. You know what output is. Output is what you get back. That's pretty much what we are going to be doing. We're going to be writing what are known as command line programs for most of this. Command line meaning that you sit there and you type in stuff into a window like that. Why didn't I actually launch idle and just do it there? I don't know. Pick the largest font possible. So you type a command in, that's your input. You get some stuff back on the screen, that's your output. And nobody uses these commands anymore unless they're hardcore command line users. Linux people tend to use a command line, they call it the terminal, a lot more than Windows users. Net use, there we are.
Computer forensics.
Yeah. So y'all are going to actually get real used to using the command line. When I say nobody, I mean the general populace, not the wizards that we are becoming. So input, typing in, output, what you get on the screen. Difference between RAM and storage is pretty clear. The RAM is what your program gets loaded into. The storage is what's your data gets saved as and where your programs are before they get loaded into RAM. So software, that's the other component of computer systems. You have all these pieces of metal and silicon and glass. You have to have software that runs them. What's the software? It's just programs, like what we are going to write, except, considerably more complicated for the most part. People used to break up, or some books break these up into a lot of different categories, but really application software is your stuff like Word. It's anything that you expect the average user to use. Games, that's application software, spreadsheets, things like that. Then there's system software. System software is the stuff that sits underneath the application software. The operating system, is the classic system software. But also stuff that controls, the computer. You don't call it the control panel an application. It's a program, but you don't call it an application. The administrative tools, the this and the that. So when you're downloading a quote app to your phone, you're downloading typically what's application software. And again, those kind of get blurred because the tools that you use to manage your phone are nice and pretty, applications. So, other people just draw the line at being operating system software and application software. But system software is typically what you use to manage the computer, and application software is what you do to be productive or have fun. So simple programming logic. We talk about algorithms. Here's an algorithm in order to calculate pi or something like that. It's a series of steps that you're going to follow. Just a sec. I meant to have this loaded up. We are real used to dealing with algorithms, even if we don't know it. If you open, a box of microwavable macaroni, it tells you how much water to add, tells you how long to heat it. That's an algorithm. Pretty complex one, huh? No, pretty simple. Driving. When you're driving someplace, your brain is internally following algorithms like if car parked in front of you, slam on brakes. You know to do that. If yellow light, slam on accelerator. These kind of things. So we're going to make a recipe. Now when you're writing what I'm going to be writing, I'm not writing in a computer language, but I'm writing hopefully in terms of something I want a human to be able to understand this. I am programming a human. I am programming a cook. I am programming a customer. Get a bowl. Stir. Add 2 eggs. Add 7 pounds of flour. Bake at 350 degrees for 45 minutes. Add 4 cups sugar. Eat. You know, whatever. Now, is that a good recipe? No, probably not. For one thing, you're not supposed to stir before you add any ingredients. For another thing, the list of ingredients is incomplete. Another is that would you add 7 pounds of flour and 2 eggs to make a cake? No. So this is a stupid algorithm. It's incorrect. But somebody could understand it, even if following it produced the wrong results. What if it looked more like this? Add 2 eggs. Add 3. Yeah. Add 7 pounds of flour. Bake. Let cool for... Okay. Now we're getting to the point where if we handed this to somebody else and we expected them to follow it, no longer is it a stupid recipe. They can't even follow it. They don't know what 3 is. They don't know what is. That's kind of illustrating 2 different errors. These are syntax errors. Syntax errors are when something is written in such a way that it's impossible for the recipient to understand. A human is a recipient for this. When we type our code in and run it in Python, Python is the recipient. So we're going to have to make our stuff follow the syntax that Python is. You know, what if several of these lines have been written in French? You know, might be good syntax for French, but for French-speaking people, but it's not going to be good syntax for English-speaking people. That's just like there are different programming languages. Besides Python, there's Java and C++, and all sorts of different programming languages. The syntax we're following will be specific to the Python language, and if you cut and pasted it into a C++ program or a Java program, it's not going to work. So, you can have syntax errors. Something is not understandable. That's really vague, but Python is really picky about certain things and not picky at all about other things. One of the things it's very picky about is indentation, believe it or not. You have to indent things correctly or the program will not even run. And that's totally different than a lot of other programming languages that don't give a hoot about indentation. The words that Python uses, like print and stuff like that, a vast majority of them are lowercase. If you put some uppercase letters in them, it's not going to run. If you misspell them, if you spell print with 2 I's, it's not going to run. If you mix up your lowercase L's and your 1's, if somebody gives you an example of code and they meant for it to be a lowercase L and you typed in a 1, they look similar, but the computer's not going to understand it. So those are syntax errors. So that just flat out breaks the process. Can't even begin. Or if you have managed to begin, then you're going to hit to a point where you come to a screeching halt. So the other kind is a logic error. I'll probably give a different name to that later on. I'm not coming up with the one that the How to Think Like a Computer Scientist calls it. They call it a semantic error. But a semantic error, a logic error, is when all the instructions are understandable. Add 3 teaspoons of salt. We've gone in and we've corrected our typos. Let cool for 1 second. But it's not right. We're not going to get the right results. We have our recipe. We can follow it. It's all perfectly understandable. It's not very complex. It's a bad recipe, and the instructions are in the wrong order. So, if this is understandable at all, like what if get a bowl had been put down here, and add 2 eggs to bowl, add 3 teaspoons of salt to bowl, We didn't even have our bold yet. That would be more along the lines of a syntax error, where the words make sense, but the things are done out of order. If things are done out of order, the program can't understand it. It may not even be able to compile. You know, if you try to use something before your program knows what that something is, it's not going to work. If you try to print a user's name, but you don't have that information yet, it can't do that. So things have to be in the right order, and a lot of what we're learning in this class is how to arrange our thoughts and concepts in order so that we can express them in such a way that the computer will understand them. So semantic error, logic errors. When the process runs, so to speak, but does not produce the correct result. So just for example, input temperature. If temperature, yeah, like you can see that. Let's blow the text up a little bit. If temperature is less than 32, print it is a liquid. This is not a programming language. I am doing what's known as pseudocode. When you're writing a general description of what you would want the program to do, but it's not written in any language particular. Else, print it is not a liquid. Maybe that 32 looks familiar. That's the freezing point of water. If the temperature is less than 32 degrees, is it really a liquid? No, it's a solid, assuming normal circumstances. The logic of this is wrong. But if I expressed it correctly in code, it would run and it would display some output. It would just display the wrong output. If I ran the program and I typed in 10 and it said it is a liquid, I wonder what that it is. You know, water is a liquid. That's not the right result. I wanted it to say it is not a liquid. Even better would be if I said, you know, it is ice. Something like that. Semantic error, logical error. The code is okay in terms of syntax errors. You've corrected all the syntax errors, but the logic is wrong. I will add this line to it. So semantic error, logical error is when the process runs, the syntax is correct, but does not produce the correct result. The syntax error is when something is not understandable to the computer, to the system, whether that system is somebody baking the cake or whatever. So now we've been talking effectively about pseudocode. This is pseudocode. It's not written in a form that you could write that you could pass this to a factory and the factory would be able to bake a cake. They'd have to be a lot more detailed about the process that they followed. And really, we should probably be a lot more detailed too, as well as making it correct. Pseudocode is when you word things in a loosey-goosey way that describes what you want the program to do, but you don't get bogged down in the details. And I did that here. Here's some pseudocode. We're going to do another one. I want to double a number. So, following the simplest pseudocode, you can make your pseudocode really complicated so that it looks like a programming language, or you can make it very general. Input my number. Set my answer equal to my number. I'm going to use the word times, even though it's childish. Times 2. Yeah, I should have made it multiplied by. I'll do that so that future generations won't think I'm silly. Multiplied by 2. And then output or print or display my answer. This is an algorithm. This is pseudocode for doubling a number. If you handed this to a programmer, they could write a program really quick that would do that. Is this really very detailed? No, we're skipping a lot of steps. For one thing, how's the user going to input the number? How do they know that they're supposed to input a number to begin with? You'd probably need some kind of output here that would display what's known as a prompt. A prompt is when you tell the user what they're going to type in, and then you give them a chance to type it in. But that is pseudocode. Pretty primitive pseudocode. If we wanted to come up with a better version of it, we're going to go through a couple of iterations on making this better. We might want to output. I'm going to switch over to using the word print. The books tend to use output. But I guess if you're printing, you're not really printing. You're not sending it to a printer. I'll leave it output for now. So output, please enter a number to double. And then input my number. Set my answer equal to my number multiplied by 2. Output my answer. So I'm going to change this line to output the number doubled is. Like that. That's getting closer to something that you might actually want to start working on a computer. Yeah. You tell the user what they're doing, what they're expected to type in. Maybe the details have to be even more specific than that. Maybe we want them only to enter whole numbers. We let them input the value. The word input means that they have a chance to type it into the keyboard. Then we do this. Set my answer equals to my number multiplied by 2. Now that's totally not computer programming language in any particular type. We're using the word set here. Yeah, there haven't been a computer program that used the word set for a long time. But in pseudocode, set means that you're going to be putting a value into what's known as a variable. A variable is something that it is a named place in memory. Why do you give it a name? Well, your computer has 8 gigabytes of memory or whatever. Maybe you think that you could store some useful data in memory address 1,003,241. Most likely that's being used by something else. In the vast majority of cases, you don't want to specify addresses in the memory, and most programming languages no longer even allow you to do that. Instead, you create a variable. A variable references a place in memory, but you don't know what that address is. You don't know if the name that you've typed in is stored in, byte number 72 or byte number 2,072,000,072. It's a named place in memory that can contain a value, or that will contain a value. So really, it's got 3 parts. It's got a name. It's got a type, even though you may not know what that type is. But what are the different types of data you might have? To begin with, you could have strings. Strings are series of characters, names and stuff like that. It might be a number, but there's more than one kind of number. There are whole numbers, and then there are floating point numbers. There are numbers with decimal points and numbers without, and they are actually treated significantly different in the computer. So that's what type means. It's what kind of data is stored in it. That's the kind of the data. In some languages, in the vast majority of languages, you have to specify what kind of data is stored in that variable. You have to say, okay, I'm going to have a variable named age, and it can hold whole numbers only. Python's not like that. If you want to create a variable and stick a whole number in it, go for it. And then if you want to turn around and store a fractional number, a floating point number in it, that's totally okay. Scripting languages, of which Python is one, usually are not known as strongly typed languages or strictly typed languages. Strictly typed languages are ones where you have to define every variable before you use it, and that controls what kind of data can be assigned to it. And you get an error, or it won't compile if you're trying to put the wrong type. So if you have what's known as an integer, which is a whole number, and you have a variable that's only supposed to hold ints, if you try to store someone's name in it, it's not going to work. So anyways, all variables have a name. They all have a type. Underneath it all, they have an address of where that memory is located, but we don't care about that. We have no way of accessing it. And then they have a value. So those are the three components of every variable. Like I said, some languages are very specific. You have to give it a type. In Python, we don't have to give it a type. You can find out the type. So I'm going to pop open idle. I went to the start menu. Feel free to play along. Type in IDLE. Select the top choice. While it's open, you may as well, dock it down here on the taskbar. So I'm going to pin this program to taskbar by right-clicking on it. Okay, I'm back in the shell now. We're not going to usually do anything in the shell. Usually we're going to type file new and we're going to create a script. The difference between a shell is standing on stage talking, and a script is writing a script out that you can then give to somebody and they can do it over and over and over. But for now, I'm going to say a is equal to 3. A is a variable. That's the name of the variable. 3 is the value of the variable. It has a type, but we don't know what the type is. We can ask Python to tell us what the type is. To query Python to figure out the type, you use the word type, and then you use parentheses, the shift 8 and the shift 9, and you put the name of the variable that you're curious about between it. And it says this is an int, which stands for an integer. Let's create another variable. Then I'll walk around a bit and make sure everybody's doing it good. How about b is equal to 3.14159? Math people will recognize that as an approximation of the value of pi. So what type is that? Type B. That's a float, which stands for floating point. The difference between an integer and a floating point number is that an integer is a whole number only. 1, 2, 3, 4, 5, 6, 7. A floating point number is one that has a fractional component. 1.0 is a floating point number. Even though it sounds the same as 1, it's treated differently by the computer. 3.14159 is a floating point number. Let's give us one more piece of data. C is equal to Fred, or whatever name you want to stick in there. And then do type C. And you get a syntax error if you make a mistake like I did. And it says that's a string. A string is a series of characters. These are numbers. These are not characters. 3 is a number. 3.14159 is a number. This is a string of characters. A string of characters is denoted by a quote, and then a whole bunch, and then a series of letters. And the series could even be no letters, or it could be 100 letters long or 1,000 letters long, and then another quote. This language is not particular about whether you use double or single quotes. Other languages are. I'm going to always use double quotes for my strings, just because that's the way it is in C, C++, C#, Java, and any other number of languages. But you could do this as well. You don't have to type this, but C is equal to Fred with single quotes, with apostrophes. Works exactly the same in this language. I'm just going to use double quotes by convention because that's good training for other languages. All right, let me pause the recording, walk around, make sure everybody's got about to this point. A couple of things to notice. It is sensitive to capitalization. What do I mean by that? Type in name, all lowercase letters, is equal to Joe, Bob, Fred, Tony Stark, whatever. And then do print, new command, parentheses, name, Joe. Do the same thing, but make it name capitalized. An initial cap. We get an error. I'm going to close this window, open it back up, just so that all the text is up at the top so it's easier to read. So you saw that. I did name is equal to Joe. I tried to print out name, but I gave it the wrong capitalization, and you get name not defined. You just have to learn that you're going to have to capitalize and spell things exactly. So if you say somebody's weight, you don't have to type this, is equal to 180, and then you say print and you misspell weight, or usually people miss up the, the T and the H when they're typing. That's the favorite typo. Well, here I typed it correctly. There we go. Like that. That's not going to work. So things have to be precise when in terms of function names and variable names. What is a function? A function is one of these things that are showing up in purple. It's a call followed by parentheses. It tells the computer to do something. This word right here doesn't tell the computer to do anything. Sure, after we add some stuff to it, it's telling the computer to do something. But this is a variable. It's a place for holding data. It's like a truck that you load cargo into. This is a function. It's a verb. If you had that truck, you're going to drive that truck. You're going to unload that truck, We're going to print the name. We're going to determine the type of that variable. Really, you don't use that type function very often past the first day of this class. It tells us that it's a string. String being a series of characters. What if we did this? Name is equal to, and then we put double quote, double quote. That's it. Then we do type. Well, let's print that out first. Print that name. And it just printed a blank line. That's reasonable. There's no data in it. This is what's known as an empty string. It's still a string, though. If I do this, what is the type of that variable? Yeah, it's a string. It's just a string that doesn't happen to have any data in it right now. Kind of like the number, 0. If you did something like this, name is equal to Fred, but you didn't put quotes on it, that's also a syntax error. The computer has no idea what this is, what Fred is. It may be a variable name. If it was a variable name, that statement would actually work. But what we wanted it to be is we wanted it to be data. We wanted it to actually represent something that we could display on screen. So to get that to work, we should have put quotes around it. So what we have been doing is what's known as assignment. We have been assigning values. I'm going to create a new slide here. That's when you do like what we just did. Name is equal to, and Microsoft being what it is, it's putting backwards tilted quotes and forward tilted quotes, and if I copied and pasted this, it would not work. There's a way to disable that. I just forgot to do that. Smart quotes or something like that. A is equal to 3. Oh, and it also capitalizes everything when I don't want it to. B is equal to 3.14. These are all assignments. We are assigning values to it. Back up here in our pseudocode, we called the act of assignment set. But that's not a Python command. If I come back into Python and I type set answer equals 3 or whatever, it's not going to work. That's just a generic pseudocode term that doesn't happen to match any command. This thing here is known as the assignment operator. The equal sign is the assignment operator. Why is it called assignment operator? Well, it assigns. But why is it called an operator? Operators are these symbols like plus and equal and minus and the division and the asterisk for multiplication. Those are all operators. All the symbols. I won't say all the symbols. Parentheses are not operators. But all the kind of mathematical looking ones are operators. And the equal sign is the one that you use the most. because you got to store data into these variables. There's another one that you're going to start seeing, which is double equals. They mean two different things, and I guarantee that some people are going to get them mixed up, and it's not because you're dumb, it's just because it doesn't make sense that you have to do this. I'll give you an example. I'm going to actually type this in as a script now. So what I'd like for you to do is to go File, New File. Then you should get a blank screen. It should not have any of those asterisks or anything like that. If you're still typing in something that has asterisks or anything, that's not where you want to be. Okay, not asterisk, but these arrow-looking things. We want an absolutely blank screen. So we're going to say age is equal to 18. Now we're going to write a little bit more than what we did in the past. We're going to say if age equals 18, colon, print, I don't know. Wow, you can vote. This is a tab. Tabs are very important to this language. Now I'm going to run this. When I run it, it's going to ask me where I want to save it. If you brought a flash drive, you probably want to save it to your flash drive. Otherwise, just go to the desktop and create a folder. Programming, scripting, CIT1113B, your name, whatever you want it to be. And then you have to give the program a name. I'm going to call the program age. It just told me invalid syntax when I tried to run it after I saved it. Why? Because this is the assignment operator, and the vast majority of languages are very picky about not letting you use the assignment operator to do comparisons. There are some languages, if I made that 32 instead, this would be a mistake, but it wouldn't tell you, but it would go ahead and copy that 32 into age, just like 18 was. And if you were comparing two values, if you wanted to see if something equaled something else, you wouldn't want it erasing your data during that comparison. The majority of languages nowadays no longer allow that. They flag that as an error. But if you want to do a comparison, you have to use equal, equal. I may not say that when I'm reading off code to y'all. You know, I'm going to go back and change that to 18 again, because saying you can vote when you're 32 is a little bit silly. Well, you can, but okay. So when I say if age, you don't have to type this, equals 32, what I mean for you to type is age equal 32. Then if I say x equals 4, I mean for you to type x equal 4. Isn't it nice that I'm using the same words and I'm expecting you to know when to use 2 equals and 1 equals? That's just kind of a side effect of the fact that our language uses the word equals, or that symbol, to be two different things. Maybe it'd be kind of neat if there was a different symbol for that, you know, like you've seen in math, and if you ever took math where you have that, and it means that 4 gets copied into x. Well, that doesn't work in this language. I will try to use the word equal, equal. So, if I say, if age equal 32, colon, you're going to know what to type. You're going to type if age equals 32, colon. That's my goal, to always say that, but I may mess up. Just remember that if you're doing an if, you always have to do the double equals, because this means comparison. This means a single equal means assign a value. Double equal means check equality, or is equal to. No, I don't like that one because, okay. Just two different things. So if a equals 3, colon, print 3. Equal equal is a comparison operator. Check the equality. Equality. There's more than one comparison operator. There's less than, there's greater than, there's not equal to. But that's good enough. Alrighty. The idea of expressions. Where was I when I was doubling things? I'm going to go back and modify this again to make it even look a little bit better. So I'm just going to copy this slide. Come down here. Paste it here. An expression is a series of variable names and operators that evaluate to form another value. So for example, so an expression is a series of operators and variable names. And I'm going to add one more, constants. What's a constant? That evaluate to a value. Example, 2 plus 2. That's an expression. What does it evaluate to? 4. 10 divided by 5. That's an expression. So if we do this, A is equal to 10 plus 20. This is the assignment operator. It will evaluate the expression 10 plus 20 and copy that value into A. The simplest expression is just another variable name. A is equal to B, something like that. B is equal to A. A is an expression. Even though it's not multiple things, it doesn't have operators and stuff like that, it's considered an expression, but I'm probably not going to refer to it as that. Usually if I use the term expression, I mean something more complicated than a single thing. Now when I said constants, what if I did this? C is equal to A plus 10. What is C? It's a variable. What is A? It's a variable. What is 10? Well, that's not a variable. It doesn't change the way a variable can. It's not like 10 is, 10, some days and then it's equal to a different value in other days. This is what's known as a constant. Also called in some programming circles a literal. This is a numeric literal. It's literally been typed into the program. So that's why I gave this such a complex name. What is an expression? It's a series of operators and values. And a value could either be a variable name or a constant. These are values. That's a value. It evaluates. So looking at my pseudocode, this is pretty dumb here. My number multiplied by 2. Well, we have an operator that stands for multiply. It's the asterisk. So my number asterisk 2. Sometimes I'll say times. Usually I'm going to say times. If I say times, it means asterisk. Is times the nice, sophisticated, grown-up way of saying multiplication? No. But I don't want to say my number multiplied by. That's 2 words. I just want to say my number times 2. And I think everybody understands what that means. This is getting real close to the final syntax. We're going to change it now into Python syntax. So I'm going to duplicate and just call this Python syntax for doubling a number. For one thing, this word up here, doubling a number, that's not going to be comprehensible to the computer. I'm going to turn this into what's known as a comment. A comment is something that we put into the program, but it just describes something. The program ignores it. You can put your mother sucks eggs there and the computer's not going to care. Okay, how do we do output? Well, we've kind of seen it already. We use the print statement. So instead of output, please enter a number, I'm going to change the syntax to Python. The syntax would be different for other languages. And I absolutely should not be using the tilted quotes like that. And I should not be capitalizing. I'm trying to make this an actual Python program. The syntax for getting input from the keyboard is not the words input my number. It is my number equals input. If you wanted to, you could have that window opened that we were typing that code into, this age program. So just start a new one. Do File, New File, and call it double. Just right off the bat, do a save as and call it double. Because that's what it does. It doubles the number. And then type in the things that I'm typing up here. And you can hope that I'm getting them right. So far, these 3 lines should be just about right. Other than the fact that the quotes are wrong. They won't be when you type them in. Okay, this set. As I've mentioned before, there's no set word. So I'm just going to delete the word set. The rest of it is valid Python syntax. Notice that I'm mixing uppercase and lowercase. You don't have to do that, but you have to be consistent. If you typed my number all in lowercase letters, you better type in my number all in lowercase letters down here. Quite often, when I'm giving you code examples, I will just use single letters. X equals 5, A is equal to 10. Is that good programming? No. In your programs, you're going to give variables good names so that you can understand them when you come back and look at it later, or that a coworker can come and understand it. So would you use, if you were asking the user to input their weight in pounds, would you just say X is equal to input and let them type in their weight and it be stored in a variable X? No, because pages later in the code, if you try to do some calculation and you're converting that to ounces or something like that, you're not going to remember that you called it X. You want to use good variable names. The more descriptive, the better, within reason. You don't want to say the patient's weight in pounds. That's a little bit too long. But, patient weight would be okay. Patient weight in pounds might be, a little bit of overkill, but maybe not. Okay, so the last line is still not correct because that is not syntax. That would work in any language. It is just pseudocode. So instead, I'm going to change that word output to print. Instead of that plus sign, I'm just going to put a comma there. Plus sign would work in some languages, like Java, not in this one. And that should not have been an uppercase P. This ought to be pretty close to a working program. I may have made a mistake, but I'm going to type it in and see. As well as that comment describing what the program does, put your name up there. And put your date. Not your date, the date. I'd like to see that at the top of every program you turn in, even if I don't demonstrate it up here. The name, your date, and if you know what the program is doing, and you usually do by the time you've written it, come back and put a description of it. We could, go put a whole big description. This program asks the user for a number, it multiplies by 2, and it outputs it. But, this is really enough description for now. Let's go. Print. Please enter a number to double. My number equals input. My answer equals my number times 2. These variable names are kind of stupid. Why didn't I just call it number and answer? Why did I stick the word my in front of it? I guess I just like typing. The number, okay. I'm going to drag this over now. I put a semicolon here, which is incorrect. some languages, you terminate every line, every command with a semicolon. Python does not. So if you typed a semicolon there, following along with me, delete it. If you see me type semicolons, yell at me and I'll fix it. I'm going to close this window. Whenever you get too much stuff in the shell is the one with all these triple arrows, you can just close it and then rerun the program. So what I did is after I typed this program in, I went to run and I chose run module. I know you can't see these options, these words are too small up here, but I described it. Run menu, run module. So when I did that, it popped up this window. We're back in the shell now. Please enter a number to double, 10. The number doubled is 1010. Well, what do you know? I goofed. The problem is when I used input, it treated it like a string. Run it again and type in your name instead of a number. Please enter a number to double, Jeff. The number doubled is Jeff. I have a pretty significant bug in this, and I actually had forgotten that I needed to do this. This is an example of problems when you're converting pseudocode into actual working syntax. Is each language handles things differently. The problem is that my number is a string. If I did type parentheses my number, it would say string. You can't do math on a string. It doesn't know what that string is. The string could be, written in Klingon or whatever. We need it to know that it is a number. And we have to decide whether that number is a floating point or an integer. I'm just going to say that it's an integer. So here I'm going to add a line after this input line that says my number equals int parentheses. I'm adding some spaces that you don't have to add. My number. What this does is it uses another function. You can tell it's a function because it's color-coded purple. To take this string, this variable, which has a string that they typed in. Everything that you type into the computer is a string to begin with, and then you can convert it to something else. Turns it into an int, just like when we did type parentheses a, and it told us it was an int. Well, this converts it, turns it into an int, and copies it back into itself. So here we are converting the value to an integer. And I'm going to put a comment there to that effect so that when I come back later, I'll understand what this does. Convert to an int. That's enough. You can put a comment on every single line if you want to. Assembler programmers, assemblers are incredibly complicated and difficult to use style of programming, will put a comment on every line of code. I'm not going to ask you to do that, but it's a good idea to add comments here and there over parts that you might not immediately understand. This is pretty easy, huh? My answer is equal to my number times 2. I would not then go and put a comment that says multiply the number by 2 and store it in my answer. If you could read this part and it makes perfect sense, then you probably don't need to comment. Too many comments is almost as bad as no comments in your code at all. When you program professionally, you will be expected to put lots of comments in your code, but not too many. And it's just kind of a balance that you have to figure out. Okay, I'm going to see if it runs now. Please enter a number to double. 10. The number doubled is 20. Cool, it works. The code is not ironclad. The code is not reliable. What if we give it a value that's not an integer? Like I type in 10.5. It's going to blow up. You don't ever want your code to blow up. However, in the early stages of our programming, we're not going to check for every error condition. What's another error condition? What if they type in something and they goof, like they type in not only a 10, but they accidentally type in an exclamation mark or something? Again, you can't convert 10 with an exclamation mark to an integer, so we get an error, and it tells us what line number that error happened. It says line 7. I go, oh wow, I need to find that. Man, there's no line numbers. Well, there are. It's just a teeny tiny thing down there. Line number 1, 2, 3, 4, 5, 6, 7. And then I can go, okay, I see. That's the line that failed. And hopefully I remember what the error was. I actually closed the window, so I can't tell what the error was, but if I hadn't closed it, I could eyeball it. Alrighty. Everybody get this working, or are you getting syntax errors? Let me pause this while I wander around. If you're getting syntax errors, that's totally fine. To add some logic to it, some decision making, let's add another print statement, and then we're going to be done for today. We'll be just about out of time. Print, what is your age? Age is equal to input. Now what do I remember? Now I remember I have to convert it to an int. So age is equal to int age. And I know I type faster than a lot of y'all. If, and I put parentheses around my if statements quite often because it's mandatory in some languages, but you don't have to in Python. So sometimes you'll see me start to type a parentheses and then remove it. If age is less than 18, colon, tab, print, quote, too young to vote. Now that's great, but what happens if age is not less than 18? Right now it wouldn't print anything. So we're going to add an else. You don't always have to have an else for every if, but sometimes you will. See, now you got a backspace and make it say else colon. And then we will add another print statement. So underneath the else, it's now indented again. Go and vote. I know we've already voted, but you know, 2 years from now you get to do it again. Hopefully I didn't make any syntax errors, and I will be able to run this and it will work. Now the program is asking for two pieces of data. It's wanting a number to double, 30. What is my age? Well, I'm 21. Go and vote. Whenever you have something like this, you have a program where it can do more than one thing, you want to test both of those things. So I'm going to run it again and see what happens if I type in a number less than 18. Please enter a number to double. 100. What is your age? My age is 3. Too young to vote. Okay, so I tested both paths through the program. I tested both options that it can go through. I'm going to create a Dropbox for this so that those who did get it working can upload it and bail for the day. And then I'll wander around if anybody. To submit a file, you click on the folder in the Dropbox. I'm going to switch over to student mode so it looks exactly like you see on your screen. Go back to the Dropbox. In Class A. In Class A doesn't have any attachments. If you see something like that, and most of the in-class assignments won't, you're expected to follow the video. So if you missed today, you can go and you can watch the January 19 video, which I will upload and put a link to, and then you could upload it. Click on the folder name, click Add a File. I need to go and find that PY script. Even if you didn't get it working, go ahead and do this at this point, and then I'll come by and you know, get it working for you. You're going to get 100% regardless of where. Where did I save mine? Oh yeah, I saved it to the desktop. And then I had a folder called CIT, didn't I? There he is. I'm going to change the view to make something to list rather than what it was showing. Okay. There we go. Here's my, now we actually created more than one. You could upload them both. You could just upload one. Get the one that we called double for sure, because that was the lengthiest one. So you select your files, and what I did to get both of them is I held the shift key down. You click upload, you click add, you click submit. Once you've done that, you get file submission successful. When you see this screen, you know that you uploaded it successfully. The other thing you're going to want to do is we have a homework assignment. Go back to the Dropbox. Homework, install Python 3.6. I give you some instructions. I don't really tell you how to do it, but I give you, I tell you what I want you to give to me once you do it. So the first homework assignment. Wow, go your browser. Go to www.python.org with your browser. I'll upload the fixed version. Then download Python 6. You'll have, it'll default probably to the right one for you, but if you're using a Mac, you're going to want to make sure you're getting the Mac version and so on. Install it on your computer, meaning that after you've downloaded it, you run the installer. And then write a note in Word or your favorite text editor of choice saying that you did it and upload the note to the Dropbox. Or if you're not going to install Python, just write a note saying that. I want to see a file there in that Dropbox, either telling me that you did install it or that you're not gonna. And if you're not gonna, please indicate how you plan on doing your homework. Are you gonna do it in the lab over there? I asked for you to give it a specific name. You'll get a grade even if you don't match that name, but I want us to get in the habit of naming our documents carefully. CIT1113, homework assignment 0, followed by your initials. Just put that into Dropbox the same way we did the in-class assignment. And wow, we finished a whole minute early. Okay.